So, all right, in the last session, we discussed about the measures of spread. It is also called as a measures of variability, measures of spread. Okay. And today, we have an exciting topic to dive into. You are going to learn about an important statistical concept called percentiles. Okay. So let's begin by understanding what is percentile is all about, and why they are significant in or important in statistics. And then we will explore how to calculate and interpret the percentiles using formulas, right? What formulas that we need to use it. Percentiles are not just theoretical concepts, okay? They have practical applications. So we will explore the real world scenarios where percentiles can be applied, such as analyzing income data or market trends. Next, we will discuss about the advantage of using percentiles and limitations of percentiles in statistical analysis. Okay, and we will explore and also will explore how percentiles help us compare the values, understand distribution, identify outliers, and make standardized evaluations. Okay, all right. So like any statistical measure like standard deviation, range, the percentiles also have limitations. We will discuss those limitations such as their sensitivity to extreme values. Okay. All right. We will go ahead and we'll dive into the exciting world of percentiles and explore their fascinating possibilities. Okay, in this session. Fine. Today we'll start now. Let us start with the first topic. What is percentile? Can someone tell me what is percentile? You can unmute. You can talk in our in a local language also. What is percentile? Percentile is also like other measures, standard deviation, range. It is also a measure, right? It is used to describe the position of a particular value within a data set related to other values. Okay, the percent, as the name suggests, it divides the data set into 100 equal parts, with each part representing one percentile. So you have the bunch of data set. So it's something like this. Okay. Okay, let me do one thing. That is actually straight line. I'm not good in drawing. Yeah, I explain you everything. Don't worry. Let's go step by step. You have given the data set. Okay, you have so let's say you have given bunch of data. Let's say the student score. They've given you a bunch of student score, right? The marks scored by 30 students in your class or 50 students in your class. And what you do is you have all the data. So when you use percentile, what it does is it divides your entire data into 100 equal parts, and each part represent one percentile. Okay, so the percentiles are commonly used in various fields, like in statistics we use it, and what other fields, the economics, and even the case of healthcare and retail also they use it, retail and income distribution, to understand the income distribution also, right? So we use percentiles. Like I said, the percentiles divide the data set into 100 equal parts, with each part representing one percentile. Okay, okay, this is the theory part. Okay, now the question is, what am I going to do with the percentiles? What is the significance of percentiles? It is used to capture the, it is used to compare the different groups of scores. That is one advantage of using percentiles. And also, if you wanted to understand the relative standing of a particular value in a distribution, that kind of situation also, the percentiles are very much helpful. I'll explain you what is that relative value, what is the relative standing of a particular value in a distribution. I'll explain. So this is a bunch of data set. Okay, this is a bunch of data set given to you. Okay, and in this case, so this is the, let's assume that these are the, scores for 30 students. How many students? 30 students. In a class, 30 students are there. Each student's scores, we recorded here. Okay. So one of the scores here, let's take some score here. So these are, one guy scored 80, another guy scored 82, and so on. Okay, other guy got, scored 110 and so on. So what we do is, to find out the percentile for any specific value, we need to sort the data in ascending order first. Okay, we need to sort the data in ascending order. Okay, so here in this data set, in total, how many scores are there? If you count it, 30 scores are there. Okay, 30 students are there. Okay. Okay, now let us find out the percentile for any specific value. Let's take, for example, 95. Right, two values are there, 95. Okay, so we want to find out, what is the relative position of, or what is the relative standing of this 95 compared to other values in this data set. In simple term, we want to find out the percentile for the score 95. For this, we want to find out the percentile. See, percentile you might have heard about in the CSAT exam and ACT exam, they use the term, right, percentile. Okay, it gives you the relative standing. Okay, so in this case, to find out the percentile for the 95, you can take any value. So I have taken just randomly the 95. Okay, how many values, how many scores are less than or equal to 95? You need to find out that one. See, first you need to have the data. First, step one. Step two, for any given specific value, for any given specific value, you need to find out the percentile. Okay, so in that case, let's, I've taken the randomly I've considered 95. Okay, so in that case, you need to count how many scores are less than or equal to 95. Can someone count how many number of values are less than or equal to 95? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So 13. So including this one, 95, less than or equal to, right? 13 values are there. Okay, 13 scores. Right, so we have 13 scores that are less than or equal to 95. That is what we can see that. So what is the formula for percentile? There is no universal formula. If you go and check in the net, right, they use different formula. So what we will do is, anyhow, I will teach you one simple technique a little later. For the time being, what I'm going to do is I'm going to use this one. Let me do one thing. I'll just change the pen size. It's too big, it's too thick. Here, what I am going to do is I'm going to write the formula here. Number of scores. Let me do one thing. Okay, I'll write it here. Number of scores less than or equal to the specific value. Number of scores less than or equal to. So this is less than or equal to. Okay, in software, right, we use this notation, less than or equal to the specific value. Less than or equal to the specific value. Divided by simple total number of, this hash is nothing but total. Okay, total, this is number. Okay, so total number of scores into 100. Very simple one. Into 100. So this is to find out the percentile. Okay. So in this case, we are interested in finding out the percentile for this score 95. Okay. The score of what is the score of 9? And the score of 95 is in which percentile? So we'll just simply supply the value. How many number of scores less than or equal to the specific value? 13, right? Yes, Fatima, you're correct. Out of which, how many number of scores? Total number of scores are 30. 30 students are there in a class. In this, right, we are very particular about, we want to see us the percentile for a specific value 95. Okay, percentile for a specific value 95. 13 out of 30 into 100. How much you get? How much you get? 43.33, almost 44%, right? So the score of 95 is in the 43.33 percentile. The score of 95 is in the 43.3 percentile. Okay, so okay, this is the percentile. What does it say here? What does it say here? How do we interpret this one? Which means the 43.3 percentage of the scores in this data set are less than or equal to 95. 43.3 percentage of the scores in this total data set are less than or equal to 95. Okay, we can say that way. So is there any other way we can interpret this? Is there any other way we can interpret this way? For example, if I ask you a question to find out the percentage of students who scored more than 95. So in that case, what we need to do? We need to subtract this value from 100, right? 100 minus 43.33. So you get what? 43.3. You will get 56.67 percentage. Okay, we'll say percentage, which means 56.67% of the students scored higher than 95. That means the remaining percentage, remaining students. Okay, 56.67% of the students scored higher than the 95 in this data set. But in usually how we interpret this is 43.3% of the scores in this data set are less than or equal to 95. So this is what your relative standing, the 43.3% your relative standing. Let's say you scored 95, other student got 97, like you, other guy also scored 95. And there are guys, they scored less than your mark. What is the relative standing of your score compared to others? That means 43 point. So after we obtain this percentile for this specific score, you could see that 43.3% of scores in this data set or students, right, who scored less than or equal to your score. Okay, so this is how we can compare using the percentiles. We can compare the specific score to other scores in a standardized way. So it helps us to understand where our score stands related to the rest of the data set. And also it helps us to understand how well the student performed compared to other peers. Okay, how well, they compare to other peers. So that's how, right, the percentiles are helpful, okay, to compare different groups of data. Also, you can use percentiles. And if you want to understand the relative standing, right, if you want to understand where the score stands related to the rest of the data set, in that kind of situation, the percentiles are very much helpful. In the case of education, the percentiles are used more frequently. And also even the case of healthcare and even the case of housing and retail, also they use percentiles, where it stands compared to, let's say you have different salespersons and you want to understand where a specific salesperson's sale stands related to the rest of the salesperson in an office or in a group. Okay, let's say if a person is standing in 95th percentile, that means, right, so 95% of employees in your company, right, or in the sales team, in the 95% of the sales team, your score is, let's say your sale is, 1,23,000 or something like that. Okay, your sale stands in. So if you want to tell in terms of sale value in terms of percentile, how will you tell? Okay, so your sales, right, stands related to the rest. If you want to find out where your sale value stands related to the rest of the data set, in that kind of situation, you can use the percentile. Okay, let's say your sale, you obtained your percentile. Your percentile is 95%. That means 95% of the sales in your team, or or 95% of the people in your sales team, they achieved sales less than or equal to your sales value. 95% of the people in your team, sales team, they achieved the sales less than or equal to your sales. Okay, we can say that way also. So in that kind of situation, this is very much helpful. There is another simple technique, because I don't want to confuse it with many formulas. Different formulas are available. Okay, this is a simple technique. Let's say you sort the data in ascending order, first step, and determine the total number of observations. That is what we understood, right? We first said by default in this data set, the scores are in ascending order. We don't have to sort it in that case, but this is the first step. Second step is you need to determine the total number of observations. How many number of students? 30 students were there, right? So you need to identify the specific value for which you want to find out the percentile. In that case, we have taken 95. And then you need to count the number of data values that are less than or equal to that value. Okay, less than or equal to that value. Okay, not the above the value, less than or equal to that value. Okay, so in the previous case, 13 values were less than or equal to 95. So 2, 4, 6, 8, 10, 12, 13, right? So 13 values were less than or equal to 95. You need to identify. For example, if you wanted to, there is a requirement. Let's say your manager is asking, hey, can you tell me, what is the percentile for the score 95? Your mark is 95, but where do you stand compared to others, right? So 43.3. But that means, your mark is now 43% of 43% of the students in your class, their score is less than or equal to your score. Okay, so that is when we use percentiles. So these are the steps. Okay, and divide the number from step 5 by the number from step 3. So this is your okay, I will explain you what is the step 5 and step 6. So let's take another example. Okay, we'll work on a couple of other data here. So this is my another data set. Okay, now let's say we want to find out a percentile for a specific value. Okay, which value we can find out? Let's say 80. I want you to find out the percentile for this specific value 80. So this is a given data set. So we need to, what is the first rule? Sort the data in ascending order. Is that in ascending order? Yes. Next step is determine the total number of observations. How many observations are there? 6, 7, 8. Okay. So 8 are there. Okay. And we need to find out the percentile for 80. In that case, we need to count how many number of values that are less than or equal to 80. So 1, 2, 3, 4, 5, 6, right? 6 or 7. We can say 6, right? Yeah, 6. We can say 6. 6 values are less than or equal to 80. Okay. And then now what we need to do is we need to 6 values are less than or equal to 80. In that case, 6 divided by total number of observations or data points are 8 here. Okay, and this one give me 0.75. Okay, you need to multiply this by 100. Okay, so if you do this one 0.75 into 100, you will get 75%. Okay, so the percentile of 80 in the data set is, sorry, 80 in the data set is 75%. Now you tell me how you are going to interpret this. How do you communicate this to your management? They don't know the ABCs of statistics. The person is not, they don't know. So how do you communicate to them? How do you interpret this one? Number of occurrences in the numerator is 7. Yeah, right. Since 80 comes twice, right? Yeah, so it is equal, right? Less than or equal to. So we can say no 7 also. Yeah, we can use 7 also. 7 divided by 8. Yeah, we can say that was 7 divided by 8. So whatever the, let's say, let's say you don't have, let's say I'm going to put, you don't have, additional 80. In that case, how much? 6, right? Less than or equal to 8. Yeah, 6 divided by 8. 0.7, 70%. How do you interpret this one? You need to tell the story to your management. So what kind of story you can tell them? 75% of the 75% of the values in this data set are less than or equal to 80. See, your let's say this is also a score, okay? Or let's say this is sales value. This is a sales value achieved by different people in your team. Okay, and now we want to understand what is the percentile for 80, right? 80, all these are sales value in terms of K, 50K, 56K or something like that. So your manager asking you a question, can you give me the percentile of 80? How do you compute that? How many number of, you need to count how many number of values are less than or equal to 80. So here we have seen 6 and total number of values are, in this case, it will, vary. Yeah, it will be like, 7, right? Since I excluded 6 divided by 7, so you get some value. Or let's assume that that is your 0.75. Okay. The percentile of 80 is 0.75. You need to multiply this by 170%. This is a simple step. Okay. So here, how do you communicate this to your management? 75% of the values or the sales achieved by different people in this data set are less than or equal to 80. Okay, that means 75% of people in your team, right? They achieved, right? So you are, yeah, compared to them, you have achieved 75%, right? You are standing in the 75th, your stand is 75th position. Okay, you are standing in the 75th position. 75% of values in the data set are less than or equal to 80. Okay, you have achieved the sales, or 75% of the sales achieved in the data set are less than or equal to 80. That is what we can tell. We have some more examples. So when I walk you through the examples further down, you'll be able to understand the purpose of or advantage of using the percentiles. Okay. Let's take one real-time use case. Okay, let's say we want to compare the housing prices in 2 cities, Chennai and Bangalore. Okay, let's say we have collected the sales price of house from both cities and want to determine how the housing price differ between the 2 data sets, 2 cities. 2 data sets, nothing but 2 cities like Bangalore and Chennai. How the housing prices differ between the 2 cities. I just put some data here. Okay. This example, this use case demonstrates how you can use percentile to compare the data sets, right? Compare the groups. So previously we have taken only one data set. In this data set, we have, we were very particular about, for example, in the case of score, we want to understand, where the score stands relative to the rest of the data set. Okay, to take any specific value, you wanted to find out where specific values, or the specific score stands related to the data set, right? That is what we found. But in this case, this use case demonstrates how to, how you can use percentile to compare two different group of data sets. These two city, one, Bangalore and Chennai, these two are two different cities. So now you need to find out how the housing price differ between the two cities. Okay. So in this case, we need to find out first step is you need to sort the data set. It is already in the sorted form, right? It is already in the sorted, the data got sorted. And second step is you need to find out the percentiles. In this case, we want to find out the 25th percentile and 50th percentile and 75th percentiles. Let's calculate 25th and the median and 70. We don't say 50th percentile. The 50th, instead of saying 50th percentile, we call that as a median. Median is the middle value. Okay. And 70th percentile. For both the data set, we need to find out the 25th percentile, median, and 70th percentile. We need to find out for these two data sets. And then we will compare the 25th percentile for city A with the 25th percentile for the percentile value for the city B. Okay. So in that case, we will decide, for example, if the city A value is more in 25th percentile than your city B, then we will decide in the 25th percentile, the city A has higher housing prices than city B. Similarly, for the 75th percentile, we need to find out the 75th, the value for the 75th percentile. See, in this case, it is slightly different. Previously, we were trying to find the percentile for a specific value. In this case, we are trying to find out the value for a specific percentile. Value for a specific percentile. So, okay, first of all, what is 25th percentile? What is 75th percentile? What is median? That we will discuss it. At this moment, you park this case study in your mindset. Once you understand that, we will come back here and then you can find out the 25th percentile, 50th percentile. Sorry, instead of saying 50th, median, we are supposed to call it a median, not 50th percentile, and the 75th percentile. Okay, now I just go back here. See, there are some cases, I've seen it, right? In our office, we use something like this. You sort the data in, something like this, the descending order. Okay, and then see, this is the whole idea. Okay, the quartiles. Quartiles are the one most commonly used one, the measure. Quartiles are the most commonly used measure. So what is quarter? Quarters are nothing but dividing your data into 4 equal parts. Okay, 4 equal parts. Instead of dividing the data set by 100 equal parts, we divide the given entire data into 4 equal parts. The first part is your 25th percentile, second part is your median, and then 70th percentile, and then the 100th percentile. We never say 100th percentile in practice. Okay, so this is the given data set. So in this case, where the median falls. So if you look at this way, right, we can do it this way also. This is another way of doing it. Okay, these are the given data points. If I ask you to find the median, you can see that these two values are falling in the middle. These two values are falling in the middle. And what is the median here? What is the median here? All of you type it in the chat window. So just above this, how many values are? 3, 6, 7. And just below this, we have 3, 6, 7. Yeah, in the middle, we have 2 values. 7 plus 7, 14, 15, 16 values are there. It is an even number. 16 is an even number. So in that case, you need to take the 2 middle values. You need to add these 2 values and so you need to find out the average for this, right? So that you will get the median. 78 plus 78 divided by 2, you will get 78 only. Okay, 78. That is the median. The 25th percentile, how you need to find out now is just below this, we can find out the middle value. Another median. So this is your median. Just below this, you find out the middle value. So here we have 3, 6, 7. So in between here, we have 73, 72. See, so far what I discussed, that is the bookish thing. If you go and look at any blogs or anywhere, right, they use that step, but there are some steps are same, but this is a very simple way of finding out the first quartile. The 20% is also called as a first quartile. Okay. And so just beneath the mean, if you want to find out the first quartile, which is nothing but the 25th percentile, you need to find out the median again here. Okay. 70, so the middle value is 73, 72. If you add, these two values and divide by 2, you will get 72.5. This is nothing but your 25th percentile. So this 25th percentile value is 72.5. Can you tell me what is the value is there in my 25th percentile? 72.5. Similarly, can someone tell me what is the value is there in my 70th percentile? The same rule. Just above this, you find out the middle value, and then you add those two middle values and divide by 2 and give me the answer. That is what your 70th percentile value. The value is there in your 70th percentile. Okay. So which portion of the data, what value is there? That is possible with percentiles or quartiles, right? Now you tell me in 70th percentile, what value is there? All of you please contribute here. Very good. Fatima is correct. Excellent. How about others? How about others? All of you please concentrate here. What is this? I told you this is the 25th percent. The median is there here. Just beneath the median, you have the 25th percent. Just above the median, you have 70th percentile. Tell me what is the value for the 70th percentile? Just above this, you need to find out the median. What is the middle value? What are the middle values? 2, 3, 4, 5, 6, 7, right? 84 and 83 falls in the middle. So 83.5, that is what that is the value that is there in your 75th percentile. In which percentile, what value is there, that you can find out. Very good, Jay Prashant. 83 plus 84 by contribution. All of you, please type it in the chat window. Where is Ashik? Ashik is missing here. Okay, right. This is 83.5, 72. Okay, to the 25th percentile can also be referred to as first quartile. It is also called as first quartile, or it is also called as a lower quartile. Lower quartile. Okay, the 75th percentile. 75th percentile, right? Percentile is also called as the upper quartile. Lower quartile, upper quartile. When you work in a project, you are working with Americans. You don't know what term that they are going to use. That's the reason why I'm using all these terms. You should be used to all these terms. Okay, what is the median? So median is nothing, right? So this is the one, the 78 only. 78 plus these two values are falling in the middle. And just below this median, again, you need to find out the median. That is nothing but your 25th percentile. Just above the median, if you find out another median, the middle value, to find out, that is your 70th percentile. This is a simple way of finding it out. Okay. So the 75th, the value that is there in your 70th percentile is 83.5. And so lower quartile, upper quartile, they'll say, and then they say first quartile and third quartile. They use this one also. This is your third quartile. Instead of saying upper quartile, they use a term called third quartile. They might use these terms interchangeably. This is your first quartile. Or lower quartile or 25th percentile. All these terms are same. You need to be familiar with these terms, because we don't know. They use these terms interchangeably, but you need to be used to that. So, okay, now you tell me the 50th percentile. So we already seen, right? The 50th percentile is the two middle values, 78 and 78. Sorry, the 50th percent can also be, okay, this is 83.5. Okay, this is not correct. This is your 70th percentile, right? 70th percentile is your, I just correct it now here. 75th percent, sorry, this is correct only. 50th percentile can also be referred as median. But here, the 83.5, so this is your middle value. Just above this, you have 7 values. In the 7 values, if you find out the middle value, in this case, middle value, say this, right, we have 7, so 2, 4, 6, 7 is there, right? So 1 second, 2, 4, 6, 7, right? So, okay, so just above the mean, tell me what is the middle value. Here, just below the mean, these are the middle value. Okay, in this case, 2, 4, 6, 7. Okay, 1 second. We are the same value, only we have used it here. Okay, here we have 3, 6, 7 is there. So here, if you want to find, just beneath this, if you need to find out the median, right? The 25th percentile is 73 plus, 72 plus 68, right? No, 73 plus 72, okay? And here 84 plus 83, 83.5, it means that 75% of the data values fall at or below 83.5. 75% of the data value that falls at or below 83.5. That is how you need to interpret in the 75th percentile. Uh, 70 point lower quartile, 78 middle, no, not that, 83, okay, 72.5 lower quartile. Oh, very good, Prem. 72.5 is the lower quartile and 8 is the middle quartile. Yeah, we don't call it as a middle quartile, Prem. So instead you use the term the median. We don't call it a middle quartile or 50th percentile. We can also tell, yeah, that's correct, right? 83 is, 83.5 is your third quartile. Very good, right? So how about others? Are you able to understand? Prem, very good. How about others? Yeah, Fatima, and how about others? Yeah, she is able to, your answers are correct. Sudha, your answers are correct. Deepa, Bala, Anwar, all your answers are correct. How about Jayashree and Jay Prashant? You agree with me or you want to confront with me? Jivanandam. Okay, fine. So now there is a visualization called box plot. We can represent these 5 numbers, right? 5 number summary. We call it a 5 number summary. How many of you are aware of 5 number summary? The statistics students should be knowing it. 5 number summary. They'll ask you, can you tell me what is the lower quartile value? Can you give me the upper quartile value? And can you give me the 5 number summary? 5 number summary. What is 5 number summary? Let me see how many of you answered it. Very good, Fatima, you are correct, right? So, no. Here, it's not mean. You are partially correct, okay? And yes, Deepa, you are correct. Others are correct. And how about the statistics students? The minimum, maximum, the median, the minimum, maximum, the median, lower quartile, upper quartile. Look here, I mentioned all the things, the terms. Either you can call it as a lower quartile or you can call it as a first quartile or you can say 25th percentile. Here it is upper quartile. It is also called the 70th quartile. So if somebody is asking you what is the 5 number summary, minimum, maximum, and median, no mean here. Okay, minimum, maximum, median, and then you can say first quartile, or you can say simply Q1 and Q3. So these are called your 5 number summary. Q1 is quartile 1. This is quartile 3. or you can say lower quartile, upper quartile, or you can say 20th percentile, 70th percentile. This is very important. If you become a data scientist, this is the basic thing you should be aware of it. Okay, minimum, maximum, medium, Q and Q3. This 5-number summary, we can represent in a box plot. So on the extreme left, so why it is called, it is also called a box and whisker plot. Box and whisker plot. Why it is called a box and whisker plot? Because it looks like the cat's tail on the left side and right side. Hence, they used to call it a box whisker plot. But we use this term, box plot. Box plot is helpful to visualize the 5-number summary, or we plot the 5-number summary in box plot. This is your minimum value, and the extreme right side is your maximum value. In between, you can see the rectangle here, right? So this is your lower quartile, and this is your upper quartile, and this is your median. All the 5-number summary, I plotted it here. And if you notice it at the bottom, you have something called IQR, interquartile range. How many of you are aware of the I think they did not cover you, right, in statistics. But this is also one of the important topics, okay? IQR, interquartile range. So I call this one also as a Q3, Q1, quartile 1 and quartile 3. So IQR is nothing but if you subtract Q1 from Q3, whatever you get, that is what your IQR. So this one give you the spread, okay, the spread, okay. And if you see this box plot, you can see that on the right side it is slightly, stretched, right? It got stretched like anything on the right side, left side. So with that itself, with box plot, you can plot the 5-number summary. And also with box plot, you can find out the outliers. And also using box plot, you can find out the distribution of your data set. Whether the data is normally distributed or any skew is there. Okay, so in this case, we can see that right skew, right? On the right side, it has got extended, right? Right skew is there. So all these points, please remember. Okay, box plot is very much helpful to understand or to plot the 5-number summary. What is the 5-number summary? You know very well now. Okay, fine. Now we will work with some example. With that example, your understanding will evolve. Okay, so this is the given data set. Like I have explained a while back. So what is the median in this data set? What is the median in this data set? Can all of you type it in the chat window quickly? And how do we interpret this? The interpretation is very, very important. Obviously, you need to the finding out the median, quarter Q1 value, Q3 value also important. Above all this, the interpretation is very much important. Here, what is the 25th percentile value here? Jay Prashant, excellent, right? Prem, you are excellent. And Deepa, excellent, right? So can someone tell me what is the Q1 value here? Already I highlighted it, right? This is your median. This is your median middle value. So on the left side, if you see here, you have 5 values are there. On the right side, you have the 5 values are there. Hence, finding out the middle value is pretty simple. Whatever you left with in the middle, right? If you look at the total number of samples here, 4, 6, 8, 10, 11 values are there. 11 is an odd number. In the case of odd sample, you can easily find out the median, the middle value. That is 22, obviously. Just beneath this, you need to find out the middle value. Here we have 5 values. Obviously, you remove if you strike out, this one with this one, right? You're left with this one. This is what your Q1. Similarly, if you strike out this one, see, this is a very simple technique. Even we got trained by some Americans in-house when I worked with TCS. Okay. So this is a simple technique. Okay. So, this is your median. Just below the median. Again, you need to find the middle value. That is what your Q1. It's very simple, isn't it? You don't have to remember formulas, everything. Just above the median, if you find out another median, That is what your Q3. Very simple one. Okay, how do I interpret this one? It is also called as a 25th percentile, right? Percentile, which means, right, the 25% of the data has a value that is less than or equal to 20. And now, how will you interpret this one? 50% of my data has a value that is less than or equal to 22. Okay, fine. And say this is my 75th percentile. How do you interpret this? 75% up to this. Okay, so this is what we are talking up to this. The 75% of the data has a value that is less than or equal to 23. So 25% of data that has values less than or equal to 20, 50% of data that has the value less than or equal to 22, 70% of data that has less than or equal to the value 23. Pretty simple. Now, this is the trickiest part. 50% of the data lies between 20 and 23. Look here, this is what he is talking. Between, when you use this, when you see this class, that means, he is representing this one. Between Q1 and Q3, how much percentage? See here, you have the 25% of the value is there, 25% of the data is there, 25% of data is there, 25% of data is there, and here you have 25% data. 25%, 25%, 25%, again 25%. If you add all these things, 100%. So here we have divided this data into 4 quartiles. This is your Q1, and this is your median, this is your Q3. Okay, so 25%, 25%. We have divided this data, entire data, into 4 equal parts. Okay, and if somebody is asking, 50% of the data lies between which values? So here you have 25%, 25%, 50% of the data in the sense in the median, right? So around the median, here you have 25%, you have 25%. So here 20 and 20. This one might be confusing for you people. I agree that. Even when I learned first time, I got confused. Okay, so this is different and this is different. 50% of the data lies, or 50% of data has a value that is less than or equal to 22. It's pretty simple, this one. Okay, and 50% data lies between, if they ask you, that means, they are asking about this. And the between class, when you see here, that means it is about this one. So the 20 and 23, 50% data values lies between 20 and 23. So with this, you are able to understand which data lies in which location of my data set. That is possible with percentile, isn't it? Okay. Now I will give you one assignment. With that, you will be able to understand very clearly. This is a box plot. Tell me what is the, okay, here you remember that this is your first quartile Q1, this is Q3. This is your median, minimum, maximum. Let me see how many of you are able to understand quickly and give me the correct answer. So what is the first quartile value? Can someone tell me? What is the minimum and maximum? What is the minimum and maximum value? First tell me minimum and maximum. Let me see how many of you are staying awake, alert. What is the minimum value? Minimum. Okay, minimum. No, I want to know the minimum value. So these are the sales achieved by different people in your team. You want to find out the minimum sales. Excellent. Why 75? Minimum, yeah, come on. Jiva, excellent. Jiva, yeah, Jiva gave the correct answer. Yeah, Deepa, you're correct. Minimum is 70, maximum is 105. That's all. Don't panic. Don't get confused with the box plot. Okay, you don't think box plot is something different. So this is your minimum. Okay. I guess most of you got confused. This value is here, right? Sorry. There is a yeah, you are right. You are right. Why you got confused? I understood. The 70 should be here. Ideally, right? The 70 should come here. Sometimes you need to literally look at the data. Okay, and yeah, 70 should be here. And listen, I just put it here, 75. Yeah, Prem, you are correct. Prem and who else? Jayashree. Jayashree mentioned 70. You are correct. With respect to that diagram, you are correct. Jay Prashant, sorry. Jay Prashant, you are correct, right? You got confused because the 75 was located here, right? Now the minimum is 70, the maximum is 105. Now you understood. And the 80 is the quartile one. I'll tell you that one also because let me do one thing. I will fix it now itself. Yeah, so now what is the Q1 value? What is the quartile 25%? This is your Q1 value. This is your Q3 value, 70th percentile. Very good. Very good. Very good. Okay. Thank you. Thank you. Yeah. So now what is the first quartile value? All of you type it in the chat only. Give me the answer. Q1. Very good, Jiva. IT. Fat. Yes. Like this, right? Like a bullet coming out of gun. Your answer should be like that. Fat. Yes. Very good. Very good. How about Jayashree? Jayashree's contribution is required. Jayashree is not there. Okay. Jay Prashant mentioned already. Yeah. And Anwar, Deepa, Sri. Yeah, Sri, you are correct. The Q1 is this one, 80 quartile, not 77.5. So this is the one. This is the one is Q1. This is what your Q3. Okay, Q3 is 95. Are you concentrating here or not? Okay, so this is my 80 is my Q1 and Q3 is 95. What was the lowest sales achieved? 70 minimum. What was the highest sales achieved? 105. What was the median sales achieved here? What was the median sales achieved here? Okay. Jiva says 87.5. Okay. See, the median is this line. Okay, this is your line. Okay, you know, it's kind of a 90 here, right? 90. And the median is 90 here. Okay, this is 90. The median is, see, this line is nothing. See, this median need not to be there in the middle here. This line need not to be there in the middle. It can be here also. Okay. So hence don't get confused. In this case, the median is 90. Okay, fine. What was the median sales achieved? Can someone tell me what was the median sales achieved? That's what we discussed. Sorry, yeah, we discussed already. The middle 50% of the sales achieved were between which scores? I'm using the between score now. The middle 50% of the sales achieved were between which scores? Very good. Very good, right? No. Okay, yeah. So see, the question is the middle 50% sales achieved were between which scores? I will just write it here also. See, here you have the 25% of the data is there. And here you have 25% of data, or here also you have 25% of data is there. Here also you have 25% of there. So the middle 50% of the sales achieved were between which scores? The middle 50% of the sales were achieved between which scores? So between class is there, hence you need to tell this value 80 and 95. You are correct. 80 and 95. 70 and less than 90. No, not 70 and less than. So since I put this one, don't get confused. See here, the answer is this one. Sorry, this is the one. 80 and 95. The middle 50% of the sales. See, in this given data set, the middle 50% of data, right? We can, in the middle 50% of sales value, we can see that, the sales value achieved between 80 and 95. Okay, 80 and 95. You understood, right? Okay. And the next one is very, very tricky. Let me see how many of you can give the correct. Majority of the sales were above 85. Is this true or false? You need to justify that. Majority of the sales were above 85. You need to, say either yes or true. Prem says true. And how about others? Yeah, Fatima says true. How about others? The majority of the sales were above 85. True. Okay. Okay, good. Right. So above 85, we have 1, 2, 3, 4, 5 values are there. But below 85, 1, 2, 3, 4, right? So above 85, majority of the sales values we can see here. Now you tell me what is the top 25% of the sales were between which two ranges? Top 25%. What is bottom 25%? What is top 25%? That's why I explained you top upper quartile, lower quartile. I'll give you the clue again. Very good, right? You are correct. The top 25% sales were between which two ranges? Top, I'm talking upper quartile. Where is it? What is the upper quartile? So this is your lower quartile, right? This is your lower quartile. Q1 is your, sorry, your Q1 is your lower quartile. So this is the one, this line, right? This line, entire straight line, okay? This is your Q1, this is your Q3, this is your upper quartile. Yes, you got it. Fatima, you're correct. Oh, Deepa, you're correct. Aishu, you are correct. Shri, you are correct. How about others? Jayashree, no contribution. Jayashree, you are there or not in the call? Say yes or no. Are you there? Jayashree or Jay Prashant? Very good. Jay Prashant, top 25. See, this is the top 25%. This is the bottom 25%. This is the top, right? So anything about 75%. This is your 75th percentile, right? 75th. So anything above is top 25%. Top 25. This is bottom 20. If they ask you, can you give me the bottom 20% of sales between which two ranges? 70 to, you can see 80, 70 to 80, right? And here 95 to 105. All of you, majority have you answered correctly. Majority were answered correctly. In the real world scenario, if you get into a project, they will give the data set. It is your responsibility to plot the data in a box plot. Box plot is kind of a technical chart. Technical chart, it is not like a bar chart, bar or column chart. Technical chart, only a data analyst or data scientist only can understand. Even data analyst cannot understand. Only a data scientist can understand. Okay, this is a technical chart. You need to help the business people in your company to come up with the metrics like this. You need to tell, hey, I just plotted the data. So the first quartile, we could see that the sales achieved was 80 and the lowest sales was 80, 70 and highest sales. This is the kind of data you need to give it to your management. And then you can tell the middle 50% of sales were achieved between 80 and 95 and majority of the sales were above 85. It's right. And top 25% of sales were between 95 to 105 and bottom, right? This is kind of, low performing. So with this, you can understand, which people are not doing good, which people are really doing good, right? So you can compare the salesperson's sales performance. These are the applications of using your percentages. Another applications of using the box plot. Now you understood, your understanding is evolving, right? It may take time as you work on more exercise, your understanding will evolve. Okay, now so what is the majority of the sales values here? Can you tell me in this data set, what is the majority of the sales values? Five values are between 75 and 85. And yeah, the remaining five values are, sorry, the five values are between, okay, so the majority of the values we can see, right, falling between which quarter, right? This is your 25%, 25%, 25%, 25%. In this 25%, we can see the 1, 2, 3, 4. 1, 2, 3, 4 here. And here also 3, 4, 3, right? Yeah, 3, 4 and 3. And in this 25%, only 2, and here also 2. So we can see the majority of the values. Yeah, so in this case, how many data points are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? The 5 values are between 70 and 85, right? 1, 2, 3, 4, 5. Yeah, we can say this way. Okay, maybe if I move this one, we can say 5 here. Listen, let's say your Q1 is 85, right? In that case, 5 values. And okay, remaining 5 values or above this one, right? So the majority of the values are obviously this is the one, right? You can see majority 1, 2, 3, 4, 5. From the median, if you see middle value, right? So you can see the majority of the, so we can say majority of the values falls in which quartile? Maybe that is a correct question, right? I just rephrase my question. Majority of the sales happen in which quartile? Which quartile? Now you tell me, majority of the sales happen which quartile? Here, only 2 values are there in this one, right? No, in this, you have only 2 values are there. But here, if you see here, to 100 or 105, okay, we are not asking about the top 25%. And majority of the values, can we say this one? We have 5 values are here. Yes. The majority of the values are, we can 1, 2, 3, 4 values are there. Okay, 4 values are there here. But if you see in this quartile, 25%. But in this quartile, if you see only 3, yeah, here also we have 4. Okay, let me do one thing. For the sake of this assignment, I'm going to move this something like this. For you to understand this tricky question, I just moved this. Yeah, we are done. So the first quartile value is 85. And now you tell me which quartile the majority of the sales happen. Yeah, majority meaning number of occurrences, not the value. I told you different salespersons, they achieved the sales, but in the 25th percentile we can see majority of the sales, right? But here only 2 persons they achieved the maybe right 3, and here 3 and here 1, right? Yeah, first quartile major. Don't think majority of the value in sense, right? The highest value. You are not supposed to get confused with that. That is the reason why I put this question very clearly now. The majority of the sales value in the data set are between 70 to 85. You can say that way, 70 to 85. So 1, 2, 3, 4, 5. But in this quartile, we can see only 3 values, or including this lesson of 3 values. And here we can see 3 values, but here only 1 value. But here only majority of the values are there. This is very tricky one. You need to remember this. This is what I already mentioned. Okay, next one is the quartiles. So this is the one IQR, right? The quartile you are already familiar. This is the data set given to you, and you sorted the data in ascending order, and then finding out the median is very simple. You need to find out the middle value, right? You need to add the 2 middle value. In this case, how many values are there? 2, 4, 6, 8, 10. You need to take the 2 middle values and you need to add them together and divide it by 2. Whatever you get, that is what your median. So just beneath this, whatever value, yeah, here I put the line very clearly, okay? And just above this, whatever values are. So just beneath this, we have 1, 2, 3, 4, 5, right? Yeah, 5 and 6, 3, 6. And above this, sorry, here it is not correct. 1 second. 2, 4, 6, 8, 10. Yeah. Where the middle value will come. This is the one, right? So here it is, I think due to some change in this thing, right? It got confused. We just moved the value. That's the reason why. So here, just above this here 4 and just below this here 4. Yeah, in the middle we have 2. Okay. Simple thing is, simple way of understanding this one is strike out the first and last value. Strike out the next value. Okay. This is the technique I learned from that guy. Okay. So and then now you are left with the two middle values. You need to add these two values and divided by 2, whatever you get, that is what your Q2, which is nothing but your median. Now, just above this, you need to find out the Q1 here. Okay, 1 second, let me just check. Here, this is the quiz. Let me see how many of you can answer this quiz. About 50% of the data falls within the IQR. Can you agree with that? Okay, first of all, I just move this, I just make changes to this PowerPoint. So here, okay, I just remove these things so that we will not have any confusions. I just put this one. This is where the median is here. Now you tell me what is the Q1 and what is the Q3. What is the Q1 and Q3? What is the Q1 and Q3 here? Quartile 1 and quartile 3. So you need to add these two values and divide it by 2. That is what your median. Okay, just beneath this, how many values are 1, 2, 3, 4, 5, right? So here, this is what your, okay, 1, 2, 3, 4, including this. Okay, 1, 3. Sorry, you don't have to consider this one. Here, these two middle values are there, and here you have two middle values are there. This is what your Q3, this is what your Q1. Again, you need to find out the middle value, that's all, right? So you need to add these two values divided by 2, that is what your Q3, you need to add, because here, just beneath this, we have only, 4 values are, above 4 values are there. So to find out the median here, right, Q1, this is what your Q3. The difference between these two are called your IQR. What is IQR? Q3 minus Q1. That is what your IQR. Now the question is, about 50% of data falls within the IQR. Is that true? This is called your IQR. First answer this question. I will answer your question. Okay. So is this true or false? Why so much of things? This is very important, guys. Look here. You know what is quartile, right? In this data set, if you divide this data set into 4 equal parts, 25%, 25%, 25%, 24 equal part. And this is what your quartile 1, this is what quartile 3. And Q3 minus Q1. Q3 minus Q1, this area, that is what your IQR. That is what here. And here, how much percent of data it covers? 25% plus 25%. About 20% data falls within the IQR. That is true. This is true. And IQR is affected by every value in the data set. Is it true? IQR is affected by every value in the data set? Yes, majority of you correct. No, IQR is not affected by every value in the data set, right? There are some mistake here. There are some correct value. IQR is affected only by the Q3 and Q1, not the every value in the data set. Please remember that. This is false. IQR is affected only by the Q3 and Q1, right? Q3 and Q1, not all the values in the data set. Okay, now you tell me IQR is not affected by outliers. Can we see any outlier in this data set? Which one is the outlier? First, you tell me. The next thing is, tell me whether QR is not affected by outliers. Is this a true statement or false statement? Very good, very good. Lightning fast. Every value lies between. No. Prime, okay, could be a factor to affect. No. It is not. Every value lies between. See, here the question is IQR. What is IQR? IQR, the area IQR represents the Q3 minus Q1. This area is represented by IQR. See, I will just put it in a rectangle here. Not, this value, this is not going to affect this one, right? So, okay, this is the one, the middle one. Okay, the IQR is this one, the middle one, interquartile range. This is where Q1 and Q3 box plot. You remember, right? Q3 minus Q1 is your IQR. So in that case, the IQR is not affected by everybody. See, this is not the IQR is nowhere related to this one, right? It is nowhere related to this 25% rate or this 25% rate. Okay, it is between the Q1 and Q3, right? The Q3 minus Q1, that is what your IQR. The interquartile range is not affected by outliers. What is outlier here? Can all of you type it in the chat window? What is an outlier here? Yeah, it is true. IQR is not affected by outlier. What is an outlier here, guys? Come on. Outlier is a very obvious, right? Yes, you are correct. Correct. Yes, Jay Prashant. Yes, Shri and Sudha, Swarna, Sangeeta, all of you are correct. This is an outlier, right? Compared to all the other values, we can easily find out. We don't have to do any calculation. Compared to all the other values, this value is too big. It's an outlier. But does the IQR is affected by outliers? My IQR is only this range. In this data set, my IQR covers only this one, right? The IQR is nowhere affected by outlier. So with this, what we can conclude is IQR is not sensitive to outlier, whereas range, standard deviation are sensitive to outlier. If you have an outlier in your data set, that will affect your standard deviation measure output and range also. Whereas in the case of IQR, it is not at all affected by the outlier value. Are you able to understand or not? How about Jivanandam? Jivanandam and Jay Prashant, you are correct, and Fatima, you are correct. And Prem, are you? Yeah, yeah, correct, right. So I could see many of you, replied here. Between the Q3, Q1, we have 50% data false here, right? So this area is called your IQR. Hence, this IQR is not affected by the other quartiles values, okay? And IQR is not affected by outlier. This is what you are, because the outlier range is this one. It is nowhere affected, right? It is nowhere related with this one. Q3 minus Q1 is your IQR. Where the outlier coming into picture? Nowhere, right? Will that IQR can be considered between Q2 and Q4? Q2 and no. IQR is not considered. That is not a formula. Okay, the formula is Q3 minus Q1 is your IQR. Right? Q3 minus Q1 is your IQR. It is not Q2 and Q4. Okay, Q3 and Q1. So that is what your IQR. This is very important. Now the question is, what is the difference between the $1 million question? What is the difference between standard deviation and percentile? Where did we learn standard deviation? Measures of dispersion, measures of variability, measures of spread in that topic. Standard deviation focus us, or with standard deviation, we can understand how spread out the values are around the mean. How spread out the values are around the mean. Supposing your mean is there in the middle, 40, and here 50 is there, 60 is there. And here you have some, no, the heart rate. Heart rate is 80, and here you have 90, and here you have 100, and here 70 and 60. These are how far each person's heart rate is away from the average heart rate. It is talking about the spread of the values around the mean. Okay, it gives us the information. The standard deviation gives us an information about the variability of the data set. If the majority of the values are somewhere here, right? For example, you have another data set and 80, and the other person's heart rate is 84, other person is 86. That's all majority of them. Okay, and here You can see the 75 and 70. That's all. Okay, we don't have any other value. In this case, the spread is less here, right? Whereas the spread is here, let's one guy is odd rate is 56. The spread is too wide. It tells us how spread out the values are, how wide the spread is. That is what your standard deviation. What about the percentiles? It focuses on the relative positions of the values within the data set. It focuses on the relative position of the values. It gives us the insights into the distribution, and it allows for comparison of values at different parts of the data set. If you take any specific value, if you want to compare that specific value at different parts of the data set, that kind of situation, the percentile is very much helpful. For example, top 25% of the sales, right? You are focusing on the upper quartile part, upper part of your data set. Bottom 25%, you are focusing on the bottom. So here it gives you the insights into the distribution, right? You want to compare the values at different parts of the data. This is what important. If you want to compare the values at different parts of the data set, like I said, you have 20, right? The quartile one value was 20. What does it say? The 25% of your data values are less than or equal to 20. 25% of the values false less than or equal to 20. That is what 25%. The comparison of values at different parts of the data. In the 25th percentile, right? If you want to compare the values, right, the rest of the values, right? You want to compare values at 25th percentile, 50% values, 50th percentile, right? In the middle value, the 50% values are false, less than or equal to 70 in your given data set. So the percentiles focus on the relative position of the values within the data. So you can find out which data falls in which location in your data set. That is where the percentiles are very much helpful. That is what we are going to focus with the help of percentiles. When you use percentiles, that is what our focus. When you use data standard deviation, we want to understand the spread, how far the values are deviating from the middle value. That is what standard deviation. So now you understood what is the difference between standard deviation and percentiles. Standard deviation measures the variability of the values in a data set. Percentiles provide information of the position and distribution of values within the data set. Okay, and in which quartile we can see more values, less values, right? We can understand the distribution also, right? Now you understood what is 25th percentile, all the things. Next one is, what is the difference standard deviation and IQR? Standard deviation is sensitive to outlier. IQR is not sensitive to outlier. So here we have two data set. Look here, in this case B, we have outlier here. This is an outlier, very big value, extremely very high value, very extreme values are there in this data. But whereas here almost all the values are same. In both the data set, the IQR is 0. Correct? What is the IQR here? What is the median value here? What is the median value in this case? So 2, 4, 6, 7, right? So the median is okay on the. Okay, I just strike it off here. What is the median? If you strike this one and this one, this is the median, right? This is what your median. And this is what your Q1. And this is what your Q3. Q3 minus Q1 is your IQR, right? This IQR in this case, 1 minus 1 is 0, right? Q3 minus Q1. What is Q3 is 1 and Q1 is 1 and 1 minus 1 is 0. IQR is 0 in this case. In this case also same thing, right? So this is what your median. And this is what the middle value, just below the median. Again, if you find out the median, the middle value, see just beneath the median, the middle value, we have three values. The three values, what is the middle value? Q1, this is a Q1, and this is what your Q3. And Q3 minus Q1, 1 minus 1 is 0, 1 minus 1 is 0. In both the cases, the IQR is 0. What about the standard deviation? In the case of standard deviation, you need to take into account each and every value. Since you have a bigger value, if you account this value also as part of your standard deviation calculation, obviously your standard deviation value will be more. So IQR is very resistant, which means it is not sensitive to outlier, whereas standard deviation is sensitive to outlier. The IQR for both data set is 0, but standard deviation is completely different, isn't it? Okay. To summarize, we discussed about what is percentile. Percentiles are the statistical measures using which we can describe the position of a particular value within a data set related to other values. Okay, the percentiles divide your data set into 100 equal parts, and each part representing 1 percentile. And if you divide your entire data set into 4 equal parts, we call this a quartiles, right? We call this a quartiles. And we discussed about what is percentile, and also we discussed the significance of percentiles. Using percentile, we can compare the data sets, 2 different data sets, and also we can find out the relative position of any specific value in your data set using percent. That's what we discussed, and that is the advantage of using the percentile. And also we discussed about how to calculate the percentile for any given specific value. And also we have seen how we can find out the value for a given percentile. 25th percentile, what value is there? 75th percentile, what value is there? We have discussed it. Okay, fine. And also we discussed about the lower quartile, the different terms that are used for Q1, Q3, right? The lower quartile is also called as the 25th percentile, is also called as a Q1. Upper quartile is 70th percentile. It is also called as upper quartile, 70th percentile and Q3. And the median is your middle value. We never call that as a 50th percentile. We discussed about that. And also we discussed about the IQR. We discussed about IQR. IQR is, how do you compute the IQR? Q3 minus Q1 is your IQR. And what else we discussed? We discussed box plot, how to interpret the box plot. Okay, and we discussed about the box plot with some exercise. And then I discussed about one real world scenario. That is an assignment for you. Give it a try. Okay, find out the 25th percentile, 75th percentile for both the data set, and then you compare in both the data set what value you are getting in 25th percentile. Compare the 25th percentile of city A and compare the percent of city B. 70th percentile you need to compare for both data set, and median value also you can compare between 2 data set. With that, you come up with your answer. That's what we discussed about the real-time use case. Similarly, in the case of salesperson, 2 different sales team, you have South, let's you have different distinct managers are there. You want to compare one district manager performance, best district manager, sales team's performance with your another district manager's sales team performance. You want to find out. So in that kind of situation also, you can use percentile. This is what we discussed. Okay, we have 2 data set. Okay, so you work on this one, and we will review this in tomorrow's session. Don't worry. And what else we discussed? We discussed about the difference between the standard deviation and percentile. And also we discussed about the difference between standard deviation and IQR. Fine. You work on that assignment. I will just see.